All right, hopefully this is recording and is not going to cut me off. If so, then I'm just going to go with it. But anyways, how's everybody doing? This is just a quick demo slash showcase slash tutorial on my WebAssembly game engine. So the game engine itself is written in Go, and it uses a game compiled down to WebAssembly to actually drive the engine itself. And I chose Go just because cross compilation is super easy. And with the game engine and WebAssembly, the whole idea is that it can compile. The game engine itself can compile down to Windows, Mac, Linux, cross-compiled from my computer or from any computer, and then it'll just work if you give it the game code itself. But this is just a quick little demo I put together, written WebAssembly. So it's Go compiled into WebAssembly, and it's just a super simple like bunny mark style demo. You can see that we have alpha blending. You can see that they're faded out when they first spawn and then sort of fade in over time. You can see that there's a decent amount of entities, so about 28,000. I mean, it's really not the maximum that the PC can handle. This can get to about almost 60,000, I want to say, before it'll start slowing down, or at least start dropping frames. And that's without any optimization or anything like that. I'm sure I can get that number, hopefully, to about double that. But yeah, you'll see that this is just a quick demo. We can click around and it'll do all this stuff. But you notice one thing, there is no window title, which is kind of important. So we're going to actually add that, and then I can talk about the integration from like the engine code to WebAssembly and how that all works and how that's auto-generated and everything. So there's this thing called iPlatform. So each system in the engine has an interface that describes its public API or its expected public API. And then we use that to generate all of the wrapper code for WebAssembly. So that way a game written in it can just bind against what it sees in here, and it'll just work as intended. So we're going to add a new function to the top of iPlatform called setTitle, and that is just going to take a string. Right, and you'll see we already get a build error. It's just a little variable that tries to assign, platform to an iPlatform, and it's missing the setTitle method. So we just need to go implement that. So if I go to here, platform, setTitle, and I'm just going to do ebiton.setWindowTitle because this is using Ebiton. Ebiton, I just really like working with it, and it gives me all the tools I need to just get the game engine running. If I really wanted to, I could go and implement all this stuff on my own, so I could have more control over that. But for now, I like working with Ebiton, and so if I can work with an Ebiton-like game engine from a bunch of different languages, like that's pretty good to me. So we implemented this setTitle, we put it here, and then we actually implemented it. So all we need to do is type go generate, and that will generate a JSON API and then wrappers for WebAssembly. And you'll see that this platform.gen.go file turned yellow, as well as engine API. So if we go into this WASM platform gen file, you'll see that we now have a function, and you can tell by the green diff marks, called WASM setTitle. And it looks like this, and this is what WAS0 expects you to pass it, right? So it takes a context, a module, which allows us to access memory, and then a stack, and that's the argument and return value stack. So when you're first starting the function, you can pull values off of it, and that's how you get arguments from WebAssembly. And then when you're done, you put values back on the stack to pass them back to WebAssembly. So as you can see, there's this sort of auto-generated code. It's very auto-generated looking, but it takes two U32s from the stack and then calls that platform setTitle function we just implemented, right? So this platform setTitle right here, that's what we just implemented. And it will read the WebAssembly string, so it'll take the module memory, and then it'll pass in these two arguments to read the string from memory, right? So it goes memory.read at that offset, and then the count, right? Because strings in WebAssembly are just offsets into WebAssembly's memory, and then a count. And so that's how that has to work, right? So we have to read it before we can pass it in back to Go. But this just works, right? So this, if I go and rerun the game demo will still work, and everything is all good to go. We still don't have a title, of course, because the game code itself isn't calling that function. But as you can see over here, we now see WASM export platform setTitle, and that happens here in this expose function. So expose just takes the WebAssembly runtime, and this is my own implementation that gets some callbacks from WebAssembly, so that way it can call them every frame, sets up a the stack to call back and forth, and then also allows hot reloading of the game code with or without reinitializing everything. So if you just want to like tune a value while the game is still running, you can do that. If you just want to reset the entire game back to square one, it can also do that, and it will just work. So we can see that this platform set title function gets 2 arguments, or this convert and expose gets a string. That's the export name for WebAssembly to call. It takes a pointer to a function, so that's this set title. And then it also takes a wrapper function, and that is the one we passed to, or the one that was auto-generated for us, right? And all this is really doing is it's just checking the types of the function and generating a signature. It's not doing a lot of stuff. I could actually probably remove this in the future, and probably will. But for now, it's just doing a very simple setting up everything for Go to call back and forth into WebAssembly. So now let's go to our game code and actually call this. So here's some bindings that I've written by hand. I'll show you in a second how this can be auto-generated, and that's actually what I'm going to be doing later in the future. But all we need to do is just describe a function that looks like set title, right? That one that we have in the Go code. We really just have to do this, right? We just need a function that looks like this. And so that's all we need to do. Now, if we go to main.go, we'll go in our setup function, which is called after the window's already been created. So we can go platform set title, and we'll call it like gopher mark, right? It's kind of like bunny mark, but with gophers. And that's really it. So these functions are the actual functions that our engine will call through WebAssembly. So we have setup, teardown, update, render, and then this config one. Config is before Windows opened. If you want to configure certain things with the game engine, so if you want to disable logging of certain things, or if you want to enable or disable hot reloading, this is only called once, and it's before the window is actually created. We have setup, which will either be called, it'll be called after the window's opened, but before a frame is rendered, or if you have hot reloading with like reinitialization set, it'll be called after hot reloading starts, right? So if you're setting up your game code, for instance, like spawning entities or doing whatever, this can be called either once or every time you reload the game. Teardown is after the game is exiting, or when the game is exiting, and then update and render are every frame, right? So update is to update logic, and render is to actually handle rendering of entities or UI or whatever you want to do. But that's really it. That's all you need to actually work on a game in the engine. So now that we've added that new function in setup, right, platform set title, we can recompile our game, and this build script just takes main.go and then compiles it to WebAssembly using TinyGo. And this example is completely standalone. It has no reliance on the engine by itself, right? It doesn't pull in a dependency. It's only written in Go because it was easy just to, get it up and running. But I've also written this in Rust, in Zig, in Odin, assembly scripts. Really, the main languages that can compile down to WebAssembly easily. I've written examples in, and they just work, right? Because all you have to do is set up the API and call into WebAssembly, call into the engine. But nice. So we compiled that example, and now if we run our engine, you will see that if it works, that the title is set, right? So now we have gopher mark, and that title is now set to what we expect, right? And so that's all I needed to do to actually extend the functionality of the engine and immediately have it be usable from WebAssembly, right? So there was no writing a wrapper myself. There was no thinking about WebAssembly. I just made a function, exported it, and then ran go generate, and it just does all the work, right? So that's the coolest part about this engine so far, besides the fact that it can be compiled to Windows, Mac, Linux, all cross-compiled to a single executable from my MacBook or my Windows laptop or whatever, and it'll just run. So yeah, that's just something I wanted to show off for this game engine. If anyone else is trying to do something similar, because game engines are a little popular right now, unfortunately the code I'm not putting public on GitHub yet. I want to make the engine a little more usable and actually, write some, game demos in it before I say it's a success. But for now, it's very easy to get started with if you're doing something similar, especially in Go. If you're doing it in Zig or in C or Rust, there's also alternatives you can use for like WebAssembly runtime and sort of like game frameworks. So it's definitely possible. Don't think just because you're not using Go that it's not going to be easy. It's really, most WebAssembly runtimes work the same depending on the language, or regardless of the language you're interacting with it with. But yeah, that's really it. I'll probably do more showcases on this in the future. But hopefully you enjoyed this demo, or you learned something, or you just think it's interesting. And yeah, I will see you guys in the next one.